The oceans play a vital role in the Earth's climate. They cause precipitation and affect the regional temperatures.
It's like an oven in here.
I've got it. Halloween costume. Pizza Man.
Pizza man? Like a pizza delivery guy?
No, like a superhero. Like Batman, Aquaman, Pizza Man.
Can we turn on a fan? We need some oxygen back here.
Turning on a fan will not increase oxygen. It will simply move the existing air, causing increased evaporation of water from your skin. Fans do not actually change the temperature or composition of the air.
Duh.
Well, can we turn on a fan because it's really hot back here?
Bruce, would you mind plugging in the fan, please? Now, as I was saying, the currents in the thermohaline circulation system move due to convection in the oceans. This powers the entire cycle.
Hey, are these fish things supposed to be plugged in?
Yes, thank you, Bruce. The warmth of the heater and the flow of the water are very important for the fish to survive.
Whoa, this is cool. Where am I? Oh, hi, Super Big Turtle.
Bruce Rain, the thermohaline circulation system has stopped flowing.
The what?
The thermohaline circulation system. We need you to somehow get back in motion, or else the survival of many different creatures will be threatened.
That sounds serious.
It is, Bruce. All types of life forms rely on the thermohaline circulation system to live. Take this H2O pad to direct your path.
I'm on it. This water's awfully cold, Dr. Mother Nature.
Well, the part of the thermohaline circulation system you are in right now is a deep water current.
Why?
You tell me. What do you know about heat and its relationship to space?
It rises.
Wrong. This is a common misconception. Heat is not a thing and cannot change location.
Heat is not a thing. Are you serious? Are you just trying to keep my mind off the cold?
No. Heat is the transfer of energy. More specifically, heat is the transfer of energy from areas or objects of higher temperature to areas or objects of lower temperature.
Wow, cool. I mean, heat.
So, tell me, Mr. Rain, since heat is the transfer of energy, what do you know about heat and its relationship to liquids and gases?
I know energy can create, like, waves.
Yes, something like waves.
Currents?
Exactly. Uneven heating causes currents in liquids and gases. And how does that happen in this particular case?
Because warm water's less dense than cold?
Correct. Since these waters are colder, they are more dense. But there's something else weighing them down too.
I think I know what it is.
What do you think it?
French fries.
Hey, where did you get French fries?
It's my daydream, and I get French fries because I knew you were gonna say
Salt. When salt water freezes, the fresh water turns into ice, and the salt separates.
and the remaining salt falls beneath the frozen layer, making the water even saltier.
Very good, Bruce.
Yum, French fries. Why is that fish wearing an oxygen mask?
You tell me, Bruce. It's your daydream.
Because it needs oxygen.
Exactly. That's why we need you to get the thermohaline circulation system moving again. Because it provides deep sea creatures with the oxygen they need to survive. And that's only one problem with this malfunction.
Only one? What other problems are there?
Keep swimming the path on the map, and I'll show you. This is quite the journey. It is estimated that it takes about 1,000 years for this cycle to be completed.
1,000 years? I'm gonna need more French fries.
The thermohaline circulation system moves about 100 times more water than the flow of the Amazon River.
Wow. This water's getting much warmer. What's happening?
This is the part of the system where the deep water rises. It's not as dense anymore. It carries nutrient-rich water with carbon dioxide that aids in phytoplankton and sea plant growth, which then provides 50 to 85% of oxygen to the air. But since the system isn't flowing, that's not the case anymore.
Well, how can I fix this problem?
Use your super speed to swim the path to get it back in motion.
You can count on me.
You're doing it, Bruce. The water's starting to move more freely now.
Whoa! What was that gnarly drop?
That was the water density change near the polar region. It acts as the powerhouse for the thermohaline circulation system.
Awesome. But now I'm all warmed up, and you can't stop me now.
And this year's winner of the thermohaline circulation cross-ocean swim-off is Bruce Rain.
Bruce!
Bruce. Bruce, are you paying attention?
Yeah, of course.
Perhaps you can tell us how the Earth might be affected if we didn't have the thermohaline circulation system.
Well, important things wouldn't flow through the water, like nutrients. They would just sit there in the bottom of the ocean and not be used by anyone. So surface creatures wouldn't get enough nutrients in order to survive, and the deep sea creatures wouldn't get enough oxygen to survive.
Very good, Bruce.
Hey, where'd you get those fries?